Hey, hi guys, welcome back to my channel. And today, again, we are going to discuss, of course, in continuation with the same topic, and that is regarding regression analysis. And the first part of that was linear regression. So, we are going to understand a very basic model of linear regression today, right? Uh, of course, as usual, for those who are all watching this video or watching my channel for the first time, this is what my introduction is. My name is Pranav Gandhi. I work as a trainer and consultant, and my total industry experience is more than 22 years. These are the various domains you can see on the left of the screen. These are the various industries, the domains I have worked. These are some of the academics and certifications I have, and these are all my contact details. So I have LinkedIn account over here through which you can connect with me. This is my email ID, and this is of course the Facebook page which I have created. If you have not liked it yet, then please like it, and so that you can be connected, nothing else. And these are my contact details, right? So let's begin with the topic for a discussion. So we are going to discuss today simple linear regression, right? And this is the episode number 3 as far as linear regression or regression is concerned. This is what we have covered in our last episodes, when we have covered about what is regression, what is linear regression, etc. And we started with linear regression in a way with this agenda. Okay, so we have already discussed about what is scatter diagram, what is correlation analysis, right? So in scatter diagram we have seen that how two different variables can have relationship with each other, but then always this type of correlation cannot become a causation. So we have to be very careful whenever we want to write a model, and when it comes to feature selection, we shall not get into the things where uh, two variables are showing the relationship. That doesn't mean that they are actually involved in correlation. Okay, so all these things we have already discussed in our last episode. We have also discussed about how to do the correlation analysis. So there is mm, a correlation coefficient. Okay, the correlation coefficient actually gives us, this is an objective measure. This was the subjective measure. Scatter diagram is the subjective measure, which only shows us the graphical representation between the two variables, the relationship between the two variables. But correlation coefficient, which is the objective measure, it gives us the actual strength of the relationship between the two variables. And we have discussed these things in detail in last session, right? What can be the range for correlation coefficient, what is exactly mean by positive and strong relationship, negative and strong relationship, positive and moderate relationship, negative and moderate relationship, right? So all these things we have discussed. This is how we get, at the bottom you can see on the slide, that is the formula to calculate the relationship between the two variables. This is also we have discussed in the last episode. I am just taking a recap of it. Then what do we mean by beta naught and beta 1? We have discussed, right? How to get a linear regression model, or what do we mean by linear regression model is simply this, which is the equation of line. That also we have discussed. Y is equal to beta naught plus beta 1 x plus epsilon. Epsilon is nothing but error over here. This is how the model will be built, right? Here we have discussed about what is the difference between y and y hat. So this is y hat we are discussing, and y is different. Y is my actual value. Y hat is my predicted, which my model has predicted, right? So all these dots over here, these few dots are my y values, whereas for this y, this is going to be my y hat value, which my model has predicted with a linear regression, which is falling on the line. This line is called as best fit line, and it has been chosen with the method called OLS, ordinary least square error method. All these things we have discussed in the last session. Then when the model is ready with us, right, we can see actually the model parameters, and within those model parameters, there is something called as R square, which is also known as coefficient of determination. It actually represents that how much percentage of x, which is my dependent variable, if I change with whatever percentages, okay, and that whatever percentage change I am making in x, how much it is affecting as a percentage change to my output variable, okay, it will be represented by my R square. It has to be greater than some scientists say 0.8, some say 0.85, it depends, but it is always good to have it at a higher level. And when we say it has to be at higher level, means it lies always between 0 and 1. So when it comes to higher level, means it should be towards 1. Why it should be towards 1? Because we have seen that R square is nothing but this. So SSR plus SSE. Now you have to concentrate only on this term SSE. E is standing for error over here, right? So just try to imagine this, that if suppose this value becomes 0, then what will be the output? R square will be equal to 1, because SSR divided by SSR is going to be 1. So when my model is having lesser SSE, which is lesser error, my R square is going to be towards 1. So that is why this R square measurement is very, very important, right? One more parameter we have discussed about the prediction and confidence interval, and here the most important thing we need to understand is the prediction interval is always wider than the confidence interval, okay, corresponding confidence interval. And all these things we have discussed in the last session, right? So today we are going to discuss about simple linear regression, wherein there are some prerequisite conditions when it. So the thing is that any data scientist will get a data and will get a business problem. Now once the business problem is ready with him, he has to identify that what type of modeling he has to do, whether he shall go for regression modeling, whether he has to go for classification modeling or what. Now there are some prerequisites when you will go for regression, when you will go for classification, right? So whenever your y means your output variable, your output variable. Variable means your output. आपको what you desire, what output you want. If that output is continuous, if there is only one x, single x means only one x, then you will go for simple linear regression, right? So your y has to be continuous. Your x can be continuous or discrete. If your x is discrete, you will convert your x into dummy variables. Now your y is whatever output you are expecting, your x is your input. So when you write a model, and of course we are discussing predictive analysis, so there has to be the output as predictions. So in such scenarios, when there is only one x given to you, that is one input only, and you have to predict the y, that is your output. In such a scenario, you will build a simple linear regression model. And in that, if suppose your x, which is your input, if it is discrete in nature. Now what is discrete and what is continuous? We have already created the videos for that. For new learners directly watching this video, please go back and watch other videos which I have created already, right? So when your input is discrete, you have to convert it into the dummy variables. Now what is dummy variables? So this is what your dummy variables. Suppose you want to predict something like a salary of a person, and other you are working on some industry, right? So for that particular industry, the other column given to you as a data, and this data I am talking about historical data. All these terminologies are very, very important. Historical data. So in history, if the gender is male, this is the salary. If the gender is female, this is the salary. If the gender is male, this is the salary. If the gender is female, this is the salary. If the gender is female, this is the salary. If the gender is female, this is the salary. If gender is male, this is the salary. Now this sort of records, and maybe 10,000 records given to you, and now you have been asked to predict a salary for future outcomes. Like you will be only given with the gender. The information will be given, the inputs will be given as a gender, and your model shall predict the salary. If suppose this is the case, then what happens over here? Because you are going to work on because salary is a continuous output, you will go for regression maybe, because salary is your continuous output, that is y, and here y is continuous. So because the output is continuous, you will probably go and build a regression model. Now while building the regression model, you have to understand one thing, that You have been given one input variable, and that too with male and female, which means it is in text format. Now regression models don't understand this text data. That is why you have to convert this text data into dummy variables. What is the meaning of converting it into the dummy variables? Is simply converting it into the numerical format. So if a gender column is there, you will simply convert every record which is carrying male value to probably 1 or 0. It's not like male, so it is not biased towards any gender or something. You can either give male as 1 or 0, female as 0 or 1. And you will convert all these values for all the records. Now once you convert these into zeros and ones, you may call it as gender dummy variable. You can give any name you want. But the thing is that while writing a regression model, the values has to be, whether it is for X or Y, it has to be numerical format. And that is why we create dummy variables. Right? So, what are the things we have understood is, first, whenever I have Y continuous, to X single, whether it is continuous or it is discrete, I can go for simple linear regression. Only thing is that this discrete variable, now in this case it is discrete binary, right? So I have to convert this discrete variable into the numerical values, that is dummy variables, and then I can write a simple linear regression model. These are the only prerequisites of simple linear regression. That's it. Okay, no rocket science. Now let us try to understand this case study. We want to write a simple linear regression model because let us understand the business problem over here. And what is our business problem given to us? We have given waist circumferences and adipose tissue area. And if you read, by pausing the screen, if you read everything thoroughly, you will understand that this adipose tissue area tend to define this waist circumference, and this was just an assumption. This is just an hypothesis. Probably it is possible that if you know the adipose tissue area of any person, then it may probably help us to understand the waist circumference. Now studies have shown that individuals with excess adipose tissue area in the abdominal region have higher risk of cardiovascular disease. So why this study is important is because if the adipose tissue area is more, which means the waist circumference is more, and because of that there is a danger for that person to get a heart attack. So CT scan is the only technique available which allows for precise, reliable measurement of AT. So currently there is only way available, that is called CT scan. If you do a CT scan of a person, then you will come to know that how much adipose tissues are there uh, in a respective person's waist circumference. Now, what are the challenges over here? The challenges where the CT scans are not many physicians have access to this technology. If you see in your city, in your area, not everybody, every doctor is not having a CT scan machine and all these things, right? There is another danger that irradiation of the patient happens, and many a times it happens that the patient suppresses with the immune system and all, and of course it is very expensive. So a group of researchers conducted a study with the aim of predicting abdominal AT area using simple anthropometric measurements, which is measurements on your body, human body. And they wanted to find out, is there a simpler yet responsible and accurate way to predict the AT area which is easily available, which will be risk-free, and which will be inexpensive? Is there any system like that available? This group of researchers were finding out that. And this is a case study about it, that we need to find out whether the waist circumference and adipose tissue data, which is given to us and which is part of our study, the aim over here is, aim of the study is how well waist circumference, that is measurement of your waist, okay, diameter of your waist, how well it can predict the AT area within the person's body. That is the business problem given to us. So the thing over here is, when we are talking about regression, when we are talking about the scatter diagram, the only thing which we want, so when we are talking about linear regression, means it has to be like this. So if the waist circumference is more, then adipose tissue area has to be more. This is what we are trying to find out. From where? From this data. Now this is the data given to us, wherein there is a waist circumference given to us and adipose tissue given to us. Now here, for those enthusiast people have to understand that we have been given 109 observation. Number one thing is, this data is called as historical data. Now from this historical data, we have to find out whether this, what is the relationship between this AT and waist for every value given over here. From first observation to 109th observation, what is the relationship we are getting between this AT and between this waist? Now if there is a relationship, something like, as waist is increasing, AT is increasing, good. If there is a relation something like, if waist is increasing, AT is decreasing, it is also good. Because good means we can build a model. For some period of time, waist is increasing, AT is also increasing, but after that it is decreasing, maybe. So we need to find out what type of relationship we are getting over here. That is the point over here. If if we found out that yes, there is a good relationship between waste and AT, then we can build a model. Now, to try out these things, we need a tool. And there are two tools available. One is R and one is Python. And these are, both of them are, you can call them as tools, you can also call them as programming languages. You can use the functions available in these both the languages and go and check whether the relationship is available or not. If it is available, go and build a predictive model. Now, what do you mean by predictive model? The meaning of predictive model is nothing but, now this is my historical data, right? This is my historical data. I am going to use this data, and if there is a relationship available, on the basis of this relationship from this data, I am going to give new waste circumferences, new values of waste to predict my AT area. In other way, let me give you an idea about this in this way, that suppose here it is a clinic of a doctor. Now this is the entrance of the doctor's clinic. Doctor's cabin is here, receptionist is sitting over here. Every person coming here, the receptionist's job is to just measure the waste circumference, and this is the application given to her on her computer. Like we have so many apps on our mobile phone, right? Similarly, the application is given over there, and she simply have to put the waist circumference of the person, and the app will give the output, that is what is the adipose tissue area available in his body. Now if I can predict a very good, with very good accuracy about this adipose tissue area, I can simply going to nullify the CT scan, which is an expensive test, and that is why this analysis is very important, right? So this is the business problem. I hope everyone has understood what is the business problem over here. In the next session, we are going to discuss about how to write the code to solve this business problem. So of course I'm going to brief the business problem in short way, not in deep as I have discussed it right now. So those who are going to attend the next session have to understand the business problem very clearly. Okay, thank you very much for joining this session. Bye bye, take care, see you and well. And if you are new to my channel, please do subscribe the channel and try to be connected to understand and to be, sort of get the updated or updations about the new learning videos, right? And all my regular mediums are available, like LinkedIn, Facebook, my WhatsApp, everything is available. All right. So till then, till next session, uh, I wish you all the best. Bye bye and take care. But please do watch this video again and again so that you will understand the business problem very clearly. And in our next session, I'm going to write the code to solve this business problem. Okay, so if the business problem is not clear to you, then it is going to be difficult to understand what I'm doing, right? Thank you very much for joining. Bye bye. See you. Take care.